Hey there, Math Leaguers. I'm making a quick screencast because we ran out of time this morning and I wanted to make sure you understood what we ended up on. So here was our problem. Ball's 10 feet in the air. It's bouncing 80% each time, hitting the ground. I made a quick spreadsheet here, just starting with after the first bounce. It's at 8, then 6.4, etc. And you can see it continues down 80% each time. So first question was, how high is it after the fifth bounce? And that's what we call a sequence. We're just looking to see after 5 bounces how high it would be. And, you know, it's just a matter of taking 80% 5 times. And that, of course, leads us to doing this as a power, 10 times 0.8 to the fifth. Next, the question is the total distance after 5 bounces, and that is what we call a series when we're adding up all these terms together. So as we said, let's ignore the initial drop, and that's because the initial drop only happens once, whereas all the other heights happen twice, on the way up and the way down. So we'll start with the 8-footer right here, and essentially, and after 8 bounces we can just sort of count, and we can just add them up manually like this using the values that we calculated earlier. But obviously that works fine for 5 bounces, but not for lots and lots of bounces. So how can we generalize a formula for doing lots of terms? Well, here's where we got kind of rushed. Here's the original series that we want to add up, 8 plus all this stuff. If we take that series and multiply each term in the series by that ratio, the 0.8, then essentially what we end up with is each term of this new series, a term that was in the previous series, except for the very last one. We get this one by multiplying 3.3 times 0.8. Now, why do this? Well, this is a little bit of a trick. What we can now do is we can subtract the left side, and all these ones that match up drop away, and what we're left with is just the 8 at the beginning and the 2.1 at the end. Now on the right side, that's s minus s times r. And what's nice about that is the s factors out, so it's s times 1 minus r. That allows us to isolate what s is by dividing both sides by 1 minus r. So we get s equals the 8 minus the, here I put in a fuller version of that, okay? Divided by 1 minus 0.8. And that comes out to be, you know, about 29.5 feet. We need to double that because each of those heights happen twice. Add 10, and we, you know, roughly around 70 feet total distance traveled. So that's where that formula comes from, okay? It's the first term of the series minus, if we call the first term g sub 1, r is the ratio, n is the number of terms that there are. If we multiply the first term times r to the nth, that's what gave us this. Okay. Notice, by the way, that this term is not actually in the series. In other words, in the original sum, we didn't have this, but it's in the formula for the reasons that we showed. And then we divide by 1 minus r, and so that's the formula, g sub 1, which we can factor out, times 1 minus r to the n over 1 minus r. It is sometimes easier, incidentally, I should point out, to do those in reverse. And specifically, if r is more than 1, then it's generally easier to do the formula this way, so that you're dealing with positive numbers rather than negative numbers. So you'll see it both ways. Finally, the whole idea of an infinite series. You can see down here, I kept this spreadsheet going, kept multiplying by 0.8. By the time we get to row 114, the value is so small, it's not really 0, but it's close enough to 0 that Google Sheets just gave up. And from here on down, it's just showing zeros. So it's getting smaller and smaller and infinitesimally smaller. Okay? So what does that mean about our series? R to the n, as n gets very, very large, if the ratio is less than 1, so it's point something, this value here is going to get closer and closer and closer to 0, like it does here. So what happens is it just kind of drops out of the formula, and all we're left with is the first term, 8. We're still going to divide by 1 minus r, so they get 8 divided by 1 minus 0.8, which is 8 divided by 0.2, which is 40, which I got wrong this morning, embarrassingly, but it's 40. If we double that and add 10, we get 90 feet total. And it's a kind of an interesting conclusion that the ball that continues to bounce and continues to bounce, always at 80%, and will bounce into infinity, still has a finite total distance that's covered of 90 feet. So I hope that was somewhat interesting to you, and I hope it explains the formula, and I welcome your feedback, and I'll see you all next Wednesday.